Hello and welcome to Miso Maths. You find us here in the UK under a lockdown situation, but we're going to try and bring you as normal a maths lesson as we possibly can. Today in our lockdown learning episode 1, we're going to look at compound interest. Now, compound interest is a topic that requires a fair bit of prior knowledge. So if you're not familiar with the following topics, then you need to look at those before you continue with a lesson on compound interest. So before attempting this session, you should be able to convert percentages to decimals. You should understand percentage increase. You should be able to use a multiplier to calculate percentage increase. And you should understand the concept of simple interest. Now, you're not going to need a great deal of equipment to take part in this session. You'll need a pen or a pencil, some paper and a scientific calculator. Now, there are 3 parts to the session. There's the prior knowledge check that we'll look at in a minute. Then there's a couple of examples where you can take some notes down if you've got a notebook at home, or you're doing your home learning at the moment. And then there's an extension or challenge activity at the end, just to test whether you fully understand the topic or not. There's parts in the video where there's a timer to tell you how long you need to take. There's other parts where I'll just ask you to pause the video if there's anything you need to jot down. Okay, so let's get started. Let's look at what you should know already. There's 5 questions here based on the prior knowledge. I'll set the timer to 4 minutes. Off you go. Okay, that's your time up for those questions, so let's have a look at what you should have got. So, question 1, calculate 20% of 300. So there's a couple of methods you could have used here. Firstly, you could have calculated 10%, which is 30, and then if you double that, you will get your answer, which is 60. If you're quite familiar with using the multiplier, you could have just done 300 multiplied by 0.2, and you would have got the same answer that way. Okay, question 2, what multiplier would you use to increase an amount by 27%? So the original amount is the 100%, and you're increasing it by 27, which means you end up with 127%. Now to get the multiplier, you convert the percentage to a decimal, so 127 divided by 100 gives you a multiplier of 1.27. Question 3, similar question, this time it's an increase of 2%. So your total new amount would be 102%. You divide that by 100 and you get the multiplier, which is 1.02. Question 4, use a multiplier to increase 450 by 24%. So the calculation would be 450 multiplied by 1.24, giving you 558. And the last question, use a multiplier to increase 7,600 by 3.5%. So you do 7,600 multiplied by 1.035, giving you a final answer of 7,866. Okay, let's look at what compound interest is. It's one of the most widely used forms of interest, and it's extensively used in banking. It's different to simple interest because the amount of interest you earn changes each year because you earn interest on your previous year's interest. To begin with, we're going to assume that you invest an initial amount and that your interest rate remains the same for the duration of the investment. In reality, this wouldn't really be the way it works. You might add to your investment or you might withdraw from your investment and your interest rate may go up or down. So let's look at an example of this type of question. So Rachel invests £1,000 in a savings account for 5 years. She will receive 10% compounded interest per annum on her investment. How much will she have in the account at the end of the 5-year investment? So let's look at what would happen after 1 year. So after 1 year, she's going to earn a 10%. So 1,000 multiplied by 1.1 means at the end of the first year, she has £1,100 in her account. So the second year, this is where it becomes a little bit different to simple interest. You're still going to multiply by 1.1 because the interest rate we're assuming at the moment stays the same. And her initial amount this year is now 1,100. So 1,100 multiplied by 1.1 gives you a total of 1,210 after the second year. Now this process continues for each year of the investment, as we can see here. The initial amount at the start of each year changing. So after 5 years of repeating this calculation, you end up with a total value of her investment of £1,610.51. And if you wanted to know how much interest that means she's earned, you would just subtract the initial amount. So if you take off the £1,000 she put in to start with, that tells you that she earned £610.51 in interest. Now, if we look at this example in more detail, we can see exactly what we did. Essentially, we multiplied repeatedly by 1.1. In fact, we multiplied 5 times, once for every year, by 1.1. Now, if you don't have access to a scientific calculator, this is the method you would have to use. Quite often, once you've done the first iteration of multiplying by 1.1, you can just continue to press equals, and that will bring up subsequent years. You would just have to keep account of how many years you'd applied the interest for. If you do have a scientific calculator, there's a much easier way of inputting it. You could put it in as 1,000 multiplied by 1.1 to the power of 5, and you will get the answer in a much quicker manner. So, if you do have a scientific calculator, this is the button you need to look for. It's up near the top row. On this particular Casio model, it's an X with a little square. It might not necessarily be an X with a square. It could be a Y with a square or some variation of that. And the way it works is as follows. So type in your initial amount, type in your multiplier, then press that button, and that will give you the ability to input an index number. Press that, press equals, and that's how you've carried out the calculation using a scientific calculator. Okay, let's look at example 2. This time Emily invests £3,300 in a savings account for 3 years. She will receive 4% interest compounded annually on her investment. How much will she have in the account at the end of the 3 years? So, first of all, work out your multiplier. The initial amount's 100%. You add on the 4%, gives you 104%, or 1.04 as a multiplier. Type the calculation into your calculator. 3,300 multiplied by 1.04 to the power of 3 gives you £3,712.0512. Now, that's not a very sensible answer. When we're dealing with money, we would usually round our answer to 2 decimal places. So in this case, our final answer would be £3,712.05. Okay, time for you to have a go. It's probably a good idea to pause the video now. Take as long as you need to answer these 3 questions, and once you're ready, start the video again and we will go through the answers. Okay, let's look at the answers to these questions, see how you got on. So, question 1. How much interest will John earn if he invests £500 for 4 years at an annual compound interest rate of 6%? So the calculation would be 500 multiplied by 1.06 to the power of 4, which gives you that long decimal answer there, and round it to 2 decimal places. Notice the 0.23 changing to a 0.24 because the number after the 3 is an 8. So your final answer there, £631.24. Question 2, what will be the value of Fred's investment after 7 years if he invests $6,000 at a compound interest rate of 4.5%? So 6,000 multiplied by 1.045 to the power of 7 gives you 8,165.17098. Again, this needs rounding to 2 decimal places, but the second decimal place doesn't change this time because the number after it's a 0. So the final answer here is $8,165.17. Question 3, slightly different this time. How long will Sarah have to leave her money invested at 3.5% compound interest if she invests £4,500 and wants to double her money? Now, the way you would work this out is you type in the 4,500, you type in the multiplier, which is 1.035, you press the button to allow you to input an index number on your calculator, and after that it's really a method of trial and improvement. So maybe start by trying 10, that won't be anywhere near it long enough. Try 20, that'll get you pretty close, but just under 9,000, which is double the value. From there, just fine tune it by adding on 1 at a time until you get over the 9,000 mark. For this particular question, the answer is 21 years. Be careful to give the number of years as the answer, as that's what's asked for. It is not asked for the value of her money after that period of time. Okay, to finish up, it's all very well being able to work out compound interest, but quite often in an exam situation, you're asked to do it slightly differently to the way you would expect. So how can we work this piece of maths backwards? For example, if I knew Amanda had invested some money for 4 years and she received 2% compound interest, at the end of this time she had £8,659.46 in her account. How can we find out how much she initially invested? So if we were going to work this out normally, we would start with our initial investment. Here I'm going to call it X because we don't know what it is. We would work out a multiplier. In this case, a 2% compound interest per annum is a multiplier of 1.02, and the investment was over a period of 4 years, so 1.02 to the power of 4, and we know the answer is £8,659 £2.46. So I'm going to set the timer off for 2 minutes, have a play around on your calculator, try working it out on your piece of paper, and then we'll go through it in a minute. Okay, that's your 2 minutes up, so let's see if you manage to figure out how to work out the initial investment. Now, a lot of people would be tempted to just guess a number for X and keep on changing your guess until you got the right answer. You might get it right, particularly in this example where the numbers are pretty easy. It's a pretty obvious answer for X in this case, I would say. But if it wasn't, if it was an awkward number, if it was an awkward value, you need to know a more robust method for finding the correct answer. So it is as simple as this. We would, in this instance, divide the final value of the investment by the multiplier to the power of 4. That's going to give us quite a long decimal number, but remember we round it to 2 decimal places, and in this instance that shows us that the value of the initial investment was £8,000. Thank you for listening to this episode of LockDown Learning, and there will be another episode coming as soon as I can manage to upload it. Goodbye.